Break time equals 300 /porosity rate equals 95%. The surface was wrong. Every geologist said so, /porosity. No craters, just fractures, something moving beneath. 45 years building instruments to find out. The gravity matrix. Europa holds 3 times Earth's total ocean volume. Today, the spacecraft built to answer life's question. What Clipper finds will redefine habitability itself. JWST detected water vapor venting above Europa's pole. Something beneath the ice forces water through cracks. But Clipper's real question runs far deeper. Is the chemistry down there alive or pretending? Chemistry versus biology, astrobiology's hardest distinction. Clipper will push us closer than any mission before. To understand Clipper, we must understand what Galileo found. Galileo's magnetometer detected something the team checked twice. Europa's field induced by conductive fluid beneath the ice. Dr. Kivelson at UCLA spent years ruling out alternatives. By 2000, science accepted it. An ocean was there. Confirmed by what? Magnetic inference, not direct observation. Galileo couldn't see through ice. It could only listen. Reason radar changes everything. It will see through. Reason uses HF pulses. Same technology maps Antarctica. If the ocean exists where predicted, Reason detects the interface. That will convert Galileo's inference to direct observation. What caught our attention isn't the instruments themselves. It's the question the mission makes answerable, not answered. Clipper is not life detection, it's habitability reconnaissance. That distinction shapes every design choice on the spacecraft. Here's what we know and where we're uncertain. Ice shell thickness is Europa science's most debated parameter. Reason will settle that, and the answer determines everything. The tidal engine powering Europa's ocean is Jupiter itself. Jupiter's gravity flexes Europa's interior 30 meters each orbit. That flexing generates heat, enough to maintain liquid ocean. Io next door is the solar system's most volcanic body. Europa runs the same engine, channeled into liquid interior. At the ocean floor, heat may drive hydrothermal vents. Dr. Kevin Hand argued for 20 years, Europa's floor is. Not despite cold and darkness, because of chemical gradients. On Earth, hydrothermal vents support ecosystems without sunlight. Chemolithotrophs, bacteria that eat rock chemistry, are the. But here's where we must be careful about the analogy. Earth's deep-sea vents exist in photosynthesis oxygenated ocean. Europa's ocean has no sunlight, completely different chemistry. Unless Jupiter's radiation creates a chemical workaround. Jupiter's radiation splits ice molecules, creating oxidants for the. If you've followed this channel, you've seen Jupiter called a. What this dataset reveals, Jupiter may be life support too. The same radiation killing Clipper's electronics may power life. This makes Europa the solar system's prime astrobiology target. If this is shifting how you see the night sky. Now what Cassini taught us and why it changed everything. In 2005, Cassini didn't plan to fly through an alien. INMS recorded Enceladus plume composition, water C-Otwo methane. Dr. Hunter Waite spent years on those mass spectra. Methane at a hydrothermal vent means reactions or biology. In 2017, Waite's team published Molecular Hydrogen in Plumes. Molecular hydrogen means active hydrothermal reactions, water meets rock. Same reaction fueling Earth's deep hydrothermal ecosystems, confirmed. Then in 2023, reanalysis found phosphorus in Cassini data. Carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, CHNOPS complete. Every life-building block, confirmed 12 billion km from Earth. In 2005, Cassini accidentally flew through an alien ocean. Enceladus was venting through 100-kilometer geysers from its south pole. The plumes held molecular hydrogen, proof of hydrothermal chemistry. By 2023, reanalysis found phosphorus, CHNOPS complete. Every chemical life prerequisite, in an ocean we stumbled. Europa has run this same chemistry experiment for 4-5 billion. What does 4-5 billion years of uninterrupted ocean chemistry produce? We don't know. That uncertainty is astrobiology's most important sentence. Enceladus changed the politics of astrobiology funding. Before Cassini, Europa was one target among many. After Enceladus, ocean worlds aren't theoretical, they're confirmed. Not theoretical constructs, places where ocean chemistry actively happens. The 2023 Decadal Survey ranked Clipper top outer solar system priority. That consensus took 30 years to build, built on data. Europa Clipper launched October 14, 2024, 6 years delayed. Budget overruns, technical delays, 2 presidential reapprovals. The spacecraft is 35 meters tip to tip. Solar arrays must generate 700 watts at Jupiter's distance. Every engineering compromise came from the science requirements. 9 instruments, each answers a different habitability question. MISC maps surface composition, looking for organic chemistry. UVS measures UV aurora, tracing the ocean's conductivity. PIMS maps the plasma environment Europa moves through. ETHEMIS provides thermal maps, showing where ice is active. But astrobiology watches one instrument most closely, MASPEX. MASPEX identifies individual molecules, down to amino acids. If Europa vents ocean material, MASPEX will find what's there. Key question: do plumes carry ocean material or surface? JWST's 2023 detection could be sublimation or deep plume. Both. SUDA, the dust analyzer, may resolve this without. Surface dust contains radiation-processed material from the underlying ice. Dr. Kathleen Mant at JHU calls this the highest-stakes spectrometry. A single chiral amino acid detection would be historic. Chirality, molecular handedness, is biology's most reliable fingerprint. Life uses left-handed amino acids. Abiotic chemistry uses both equally. If MASPEX detects LXS in plume material, we must reckon. It won't prove life, but the evidence will be compelling. Scientific restraint distinguishes careful science from premature speculation. Now, the geography of Europa that makes this possible. Reason radar will penetrate 15 kilometers of ice from orbit. It maps liquid water pockets and potentially the ocean. No instrument was built to find a hidden ocean from. What Reason returns determines whether a lander mission gets funded. Thin ice shell, lander access. Thick shell, centuries of waiting. The radar tells us which universe we're living in. Of all mission data this cycle, Reason's matters most. Connemara Chaos is the primary candidate for recent ocean exchange. Dr. Schmidt's team modeled chaos terrain formation it needs. If the model's right, chaos matrix is refrozen ocean water. MISC will scan Connemara chaos on 3 separate flybys. 3 independent angles. That's how you rule out instrument artifacts. Now let's go to 2030, the moment Clipper arrives. Radiation will immediately begin degrading the spacecraft shielded electronics. Every flyby is optimized. Highest priority science at closest approach. The first flyby returns more data than Galileo's entire mission. Decades of our best understanding, overwritten in 4 hours. Dr. Robert Pappalardo has been preparing for this since 1999. His 1999 Nature paper methodology was careful to the point. 25 years later, that conservatism turns out exactly right. Here's the framework: what to watch when Clipper data arrives. First, reasons ice shell thickness result. This is the gating. Second, whether MASPEX detects complexity beyond background organics. Third, the one our team watches most, chirality data. If 2031 confirms organic complexity above background, it exceeds Cassini. What if it finds nothing? What does absence tell us? Null results constrain the search space. They eliminate hypotheses. A sterile Europa tells us chemistry doesn't guarantee biology. That result matters even more for the Fermi paradox. Chemistry without life in 4-5 billion years, universe may. Either outcome transforms our understanding of our place in the. We take the mission timeline seriously, the weight has. Europa Clipper carries a plaque. It tells you everything. Ada Lemon's poem, Frank Drake's equation, 26 million names. Voyager sent a message to stars. Clipper sends one too. Those who grew up with Voyager understand why this mission. The data coming back from Europa between 2031 and 2034. It will still be debated in the 2080s like. What we find most striking, this mission is designed for 9 instruments, 49 flybys. One question: is life there? The answer arrives as data, careful, provisional, debated. Not a press conference, evidence tested for years. That is, in our assessment, this mission's most important truth. We waited 45 years. The data will be worth waiting. In 2031, when Reason's first ice profile appears, history. Either Europa tells us we're not alone in our solar, or it tells us life, even ideal conditions. Either answer is among the most important our species will. The iron in your blood was forged in a dying. Full Europa Clipper investigation is pinned in the comments below.